Okay, now I'm going to show you how to get samples into the SEM. So in this box you should find all the different sample holders. The one key component that you need is this. On the bottom you can see it's got this indent here which will match the sample holder of the SEM. So it's got these two locking pins here. The bottom one locks this whole thread in place, and on top you can put all sorts of different things. Let's say you got you want to look at cross sections, you could use this tool. You want to look at normal SEM stubs with those little pins sticking out of them, you could use this one here. Today we're going to use this holder. So I'll lock it in place, and then I'm just going to put the SEM standard. So we'll take our stub, place it in one of these holes, and just very gently, because it's very easy to strip these threads, I'm going to lock it in place. Okay, now we bring that over to the SEM. Now we want to load a sample into the SEM. So step one, open up the software. No password, just click OK. So right now, if I try and open the SEM, you can see it won't open. It's under vacuum. So we need to get it to atmospheric pressure. So I'm going to click air here, and then I'm going to start 4 minutes on the timer. And after that 4 minutes, the chamber will be available to open. So while the chamber's getting to atmospheric pressure, I'm going to close this interface here, and I'm going to take a photo of the sample. I go to camera navi in the SEM software here, and place the sample with the flat side of this holder married to the flat side of this holder under here. And I can click movie in the software, and you've got a couple of different lights here. There's a light on the side you can turn on. That one's usually good. There's also a brighter light at the back here, which is usually a bit too bright for the metal samples. It's not too important. As long as you can recognize where your samples are, then it's good enough. So that lighting looks good enough to me. I'm going to click capture. Next step is to determine the height of your sample. So we'll bring it over in front of this measuring tool here. Looks like this. So make sure to get down low and measure the tallest part of your sample. So right now the tallest that I can measure is 9 millimeters. Just keep that number in mind, 9 millimeters. So I can open up the specimen exchange interface, choose the diameter of the specimen stub you've used. So in this case, it's 51 millimeters. Next. So that number, 9 millimeters, I'm going to grab this green ball here and drag it up until it says 9 millimeters. Next. And now I can't do anything until I fully open the door. And that will enable this stage move button, which right now is grayed out. So I won't let me move the stage until I've 100% pulled out the door of the SEM. So we've still got a minute and a half to go before that's ready. Four minutes up. Door should open now. Yep. Okay. So use two hands and pull it 100% of the way out. There's a little sensor that can tell if the door's all the way open. And now we can use the stage move button. So between setting the working distance over here at 5 millimeters and the height of your actual sample, now the stage is moving to an appropriate height so that the sample will just fit inside the chamber and will be as close as we can be at this 5 millimeter working distance. So again, we've got the flat side here. We marry that against the flat face up here. And this is a little stiff. So push it all the way to the side. All right, now what we're going to do is start to close the door very carefully and just watch and make sure we're not going to bang into that middle plate. We want to be nice and close, but we don't want to hit. Just scraping them. All right. If your sample's too high, you feel it's even too low, you want to move it up or down, withdraw the SEM door all the way out again, and then the up and down buttons will be available. I think these step sizes are around 1 millimeter at a time. So move your sample up or down as needed, and then try again. Okay, now you can hit evacuate. And once the sample is evacuated, you can start your SEM session. All right, so once you have your sample in, and while you're waiting for the vacuum, you can set up the alignment of the webcam. So you click on alignment on the bottom right-hand side of the screen here, and align the diameter of this red circle to the circle of your sample, and click complete. Once it's reached pressure, it should say run here, this status at the top left of the screen. So I'm going to click start to turn on the electron beam. Okay, first things first, let's head to this optics tab here, and then let's single left click on the right hand side of the screen here, which will navigate to our sample. So what will typically happen is, because we started out viewing this pit in the middle of the sample holder here, so the contrast and brightness is way too low. So I'm just going to hit the auto contrast and brightness, and that'll help get me started. The next step is we're probably like very out of focus. So I'm just going to make it really out of focus. So you might start like this and everything looks super noisy and you're wondering where you're supposed to be. So a good hint about how out of focus you are is this working distance here. So this working distance represents the focal point of the electron beam. So when we loaded our sample, we made it so that our sample was the highest point, and that working distance was 5 millimeters. So you'll notice as you turn the focus knobs here, we're changing that working distance. We're changing the focal length of that electron beam. So if you're totally lost, just head to 5 millimeters and start there. All right, so I'm going to zoom in a little bit. Actually, because of the resolution of this screen, I'm missing some information. There we go. So I'm going to go back to this kind of mode because I can't see this extra information at the resolution for this training video. So, but while you're operating, you can run in this mode here so you get a bit of a larger view. But I'm going to run in this mode here. All right. So I'm just going to zoom in a bunch, sort of coarsely focus. Oh, another important factor too is to choose your accelerating voltage and spot intensity. So I've got a nicely conducting sample and I want to image at highest resolution as I can. So one thing you can do is check the guide over here. So I want SEM high vacuum, more than 10K magnification. So here's some recommended settings here. So you can either click apply, or you can see this instrument is already at 15 kilovolts, 30 spot intensity, short working distance, which are the same for the settings here. If you have samples that are charging up a bunch, you could try a low vacuum mode or a variable pressure mode. Your resolution you achieve won't be as high, but you can reduce some of that charge up. So we're going for optimal resolution settings. This instrument does have a backscatter detector, but I'm just going to show the secondary electron detector today. All right, so I'm going to zoom in to about 10K. And I'm going to start by aligning the electron beam. So we can move around on the sample with this tool here, as well as left-clicking anywhere on this bulk stage. And I'm going to get the focus as best I can. Actually, I'm going to go into this reduced mode here. So it's a scanning electron microscope. You can see we're scan, scan, scan. The slower that we scan, the better signal-to-noise ratio we're going to get. But that also means that the response rate is really slow. So it's very hard to focus and align when the response rate is so slow. So I'm going to use this reduced mode, which is going to give me a smaller window to work in, faster refresh rate, but still better signal-to-noise ratio because of the smaller area it's scanning over. Auto the contrast and brightness. Find a sphere that's a nice kind of size to help me align everything. Get position. All right. Well, maybe I'll zoom in a little bit. I'll zoom in to, say, 23K. Focus. Using the fine focus knob now. Come back up to 10K, where I'll do my alignments. Okay. So you can click the alignment button top here. And I'm going to start out by the aperture alignment. And you can see now this stigma/alignment buttons, alignment is highlighted. So now we are interacting with the alignment that we can see on the screen. So I'm just going to make it a lot worse so we can see. So we want to minimize the amount that right now it's moving in and out of focus. And as it moves in and out of focus, if it's all aligned, we shouldn't see much movement. Right now we have a bit of, let me see, I feel like I made it better even though I was trying to make it worse. There we go, so there's a lot of Y wobble to it. So I'm going to turn this Y until I get no Y wobble in the image. Getting better, mostly X wobble, so now I'm going to turn the X. Getting much better. A little bit of Y left, maybe. There we go, looks great. Okay, now let's do the same for the Sigma Align X. So the Sigma Align X has an X and a Y component. So make sure to adjust both. So I'm going to start with, it's always good practice just to make it worse and then try and make it better. If you try and make tiny adjustments, it's really difficult to look at. So I think this was already pretty well aligned. It's kind of worse, better. Make it a bunch worse so I can really see the effect. That looks pretty good. Okay, now it's time for the stigma align Y. And again, we have an X and Y component of the stigma align Y. So we maybe have a little Y wobble to start with. So I'm going to adjust the Y. I think it was already pretty aligned. The previous person probably already used the same accelerating voltage and spot intensity, and so it's aligned already. You'll need to adjust the alignment every time you change the accelerating voltage or the spot intensity. So you might want to start by choosing a spot intensity, ideally 15 and 30. And if you can see your sample is charging up or melting or degrading, you can try turning down the acceleration voltage. And once you've chosen an accelerating voltage that isn't damaging your sample, then you could align it. So you're not spending a lot of time aligning at a voltage that you're not going to use anyway. Make that a bunch worse. Better. Worse. Better. Okay, looks good. And now when we're out of all that alignment mode, you can see that stigma is selected. So the stigmation of the beam is we want a nice round circle shape to our electron beam, but it gets out of shape. It becomes more like an oval. So you can adjust these until the focus looks best. And you should be all aligned. Another way to tell if sometimes, we've got these really nice spheres, so that makes it easy to align. But you can tell that your stigmation is way out of alignment if you change it. And then as we go in and out of focus, see how as I go in and out of focus, it's stretching. So that indicates that you don't have a nice round electron beam, you've got more of an oval instead. And now that I'm way out of alignment, I'm going to have to bring this back. It's going to be a couple of step process, I think. It's going to be stigmation first, then focus, and then stigmation again. Okay, and now as I move in and out of focus, everything should kind of evenly blur without stretching off in strange directions. That'll also point to the apertures being out of alignment. If the image is moving a lot with the focus changing, then your alignment is not very good. Okay, let's take an image. So I'm going to spin the magnification wheel. Let's aim for, say, a 20K image on these particles here. So I want a 20K image, so I'm going to zoom in to, say, 30 or 40K. I'm going to focus there. Back out, and I'll be in focus the whole way out. So this is best practice. Let's say I want to take a 20, a 10, and a 5K image, focus up at 40, and then come out and want it to adjust anything again, but I can just quickly take a 20, a 10, and a 5 image. All right, so let's hit the 20. So this button here under capture, people adjust these a lot. So make sure you're choosing an appropriate speed for your capture rate. We have a pretty good signal to noise ratio on this sample here. So even 32 seconds might be plenty. Oh, it's like 64 seconds is the fastest we can do. Always choose the highest resolution because you never recapture resolution. So you might as well take a high one. All right, so now we're ready to capture. It's like I could have done a slightly better job of the focus, but it's pretty good. And save your files to a folder on the D drive, make a folder for yourself. Always save as a TIFF so you're not compressing the image, and save. If you want to access Windows on this computer, hit the Windows button, and you'll be able to navigate to your folder. This image. Each file is saved with a metadata file, so for pixel sizes and things like that, if you want to take it into ImageJ, you can easily. Let's see. So to get running again, hit this Run button up the top. And I think I'll show you also briefly the backscattered electron detector. Let's see. Choose composition. You need to make sure that on the top of the instrument, there is a dial on the left-hand side here. There's a little green light. Now it says out. I'm going to spin the dial until I see a solid orange light on in. Now the backscatter detector will be in and we can use it. Yeah, start with auto contrast brightness. And the backscatter detector won't give us as good resolution image, but it will highlight the compositional differences more strongly than the secondary electron, which will more show kind of highlight edges and give more of a textured 3D look to your samples. So maybe we'll take some images at 10K. Let's zoom in, focus. I'm trying to check the stigma. It shouldn't have moved, but feels like it's a little off. Let's take an image out of 10K. Auto contrast brightness. It's good to get in the habit of just hitting that regularly. And let's capture an image. So we can see the strong contrast here between, I think these are copper or nickel balls and or might be copper particles and a nickel background. Not quite sure. But we can see the strong compositional contrast between these two materials in the backscattered detector. So if we compare that image to a secondary electron image, to run, capture. And now we can see a bit more of the texture, the sort of shape and depth of things, because this bit of secondary electron images will inherently induce a bit of a edge contrast, a brightness around edges. So if we open up the ESC image side, you can see the contrast between these two styles of images. In the secondary electron image, you can even see maybe some of the roughness on the surface of the particles, more so than you can in the backscattered image. And some of this depth here is kind of lost in the backscattered image compared to the secondary electron image. But there's a much stronger contrast between materials in the backscattered image. Okay, so once you've finished picking all your images, you can stop the electron beam. Head to specimen exchange, click air, and quit observation. So if you choose quit observation, it'll close the software after you follow the next steps. If you choose specimen exchange, it'll keep that specimen exchange window open and you can change samples. But for now, we're finishing off for the day, so I'm going to quit observation. Okay, so after about 4 minutes or so, the chamber will be at atmospheric pressure and we can open the door. So it has a sensor in the door again, so we want to pull it 100% of the way out. Recognize and let us take to the next step, and we'll take our sample out. Close the door again. And this evac exit button should be available. If it's not available, it's likely that you didn't pull it out 100% of the way the first time you pulled the door out. So we're closed. Click evac exit. The software should exit. The chamber should start pumping down. Should feel the vacuum almost immediately. And keep an eye for this light down here. Well, you can't see it in this video, but there's a little light down here under evac. It'll be flashing blue until it's reaching pressure. And once it's fully reached pressure, it'll be solid. So just check that it's a solid blue light before you leave. That's it for today.